Okay, so I'm going to show you how to do time series forecasting using statistical models and neural models with Python. First, you need to install stats forecast and neural forecast. Second, probably pandas and numpy. Numpy is not a must. Well, it's a must. It's not required, but you'll probably need it later. Path. So you need to provide the data. You can use mine. I don't care. You can either provide the file path of the CSV, or you can upload the dataset to GitHub or go to someone else GitHub. Click raw, Control C, and you paste the URL. And it's the same. You don't change anything. So yeah, you need to provide that unique ID. Unique ID is used to differentiate different sources. So for example, you have the weather in Texas and weather in Arizona. Both have weather, let's say wind speed or temperature, but both have different weather. So if you're trying to predict the weather in Texas by seeing just the weather in Arizona, you're going to be wrong, probably, because there is the same variable, but a different source. So yeah, if you only have one source, don't worry about this and just copy this code. Season length is how you divide your data. For example, if you work with hours, you use 24. If you work with weeks, you use 7. If you work with months, you use 12. Horizon, the predictions, the T plus. For example, if you work with hours, 6, an horizon of 6 is 6 hours ahead. If you work with months, one horizon is 1 month into the future. That's the predictions model. You can have, well, at least more than 6. I don't know if you can have more than 6, but 6 works. And you have, I think you have all these options. If you don't know what you're doing, just use this one, this one, this one, and this one. And you just basically copy this, auto CS, and yeah, you shouldn't have any problems. Well, stats forecast, you pass your models. If it's 1 or 20, doesn't matter. The frequency, I'm using hours, so I'm using H. If you're doing months, you use M. I don't know the rest. You probably have to Google the letter for your frequency. Number of jobs. In theory, if you have like -1, it uses all your available cores. Doesn't work for me, only uses 1, so yeah. Autoarima, especially with the amounts of data I have, around 28,000 values, takes like 1 hour and a half. So at least your first program, you should use 40, 100 values just to see if everything works. This trains the model using your data, so you just pass your data. And predict, this just stores the prediction, and here I'm printing the prediction. And I recommend you to save the model, because you have to, if you don't save the model, you have to retrain it every time that you need to do something with it. It will save it as a .pickle or pkl, and yeah, you don't need to provide anything. I think here you can provide the path where you want to store the model or models. With neural forecasting, it's basically the same. I'm using PyTorch. Why? Because if I use my CPU, it takes like 1 hour and 30 minutes. If I'm using my GPU, it takes like under 3 minutes easily. I can actually just run it now. So, the same as forecast models, statistical models. You provide the data, you assign a unique ID. Here, for some reason, I had a problem where my datetime was detected as an object rather than a datetime, so I converted and it solved the problem. Here I print my data, which is this one. Oh, you'll see it later. Here I basically say, okay, if you don't have a GPU available, a CUDA GPU available, use the CPU. I'm using the GPU. You'll see it later. You have different models. I don't know all of them. I use patch TST and long-term memory. Input size, the memory. How many values do you want the model to store behind? For example, if you're using 24, you see 24 hours backward, behind, I know. You see 24 hours of the previous data, the last value you had, and based on that, you do your prediction. And yeah, that's pretty much it with input size. Horizon, same as our ARIMA autoregressive. How many predictions do you want? Max steps is that epoch. Every time it goes through the model to readjust the values. So maybe I don't need 2000. Probably around 1000 should be fine. But yeah, it doesn't take a long time, so I just put 2000. Frequency in models is the same as statistical forecasting. Here you train the model with your data and do the prediction. If you don't pass any values to here, the prediction will be of the data you used to train it. For example, if you train it with the values of 2023, the year 2023, the prediction will be ahead, like after 2023. And here you do need to provide the name. This is the name of the folder, and I'll save them, the models. And yeah, here are the predictions of each model. Here is my data. If you notice, it's using the last value, 2024 March 31, and it's doing the prediction the next hour on April 1. And if you want to know, also if you want to use the GPU, you need to have PyTorch installed and also CUDA. You can just Google how to install how to enable CUDA for PyTorch or something like that, and you'll get a video. Just follow the steps, and yeah, if everything is working fine, you'll have a true here. If the GPU is not available or is not an NVIDIA GPU with CUDA, it will be false. So you have your model saved here. how to load the model. I need this, I think. Oh yeah, I do. No, I don't. So you need to load stats forecast or neural forecast or both, depending on which model do you want to load. With the stats forecast, you need to provide that .pql, the pickle file, and yeah, I'm seeing how to pass the data. I think it's like this, but I haven't tried. And with neural model, you provide the name of the folder. In my case, since the .py is in the same path as the wind forecast folder, so this is here. I don't need to provide the whole path, like see that blah blah blah, and I just load the models and do a prediction using new data. This new data should be here. Okay, so here I'm calling this function and passing new data. For example, if you train your model with data up to January 1, 1st of January, your model doesn't know the rest of the values, but you can provide the values of January 1, 2, 3, 4, 5, 6, or you can provide different values of another city, of some other place. Now, so you can either provide the new values or not. If you don't provide any new values, the model will just follow your last prediction based on the training set. For example, if I run this, I will create an Excel. Okay, so you need to pay attention to most of this part. I'm just basically testing my model to see how accurate it is in multiple days. So here, this is only neural forecasting. I don't have the stats forecasting here. This is the real values, and this is the results of the benchmarks and the predictions. Yeah, the unique ID, as I said, doesn't matter if you only have one source. Yeah, that's pretty much it. You need to do most of this. I think there's an easier way, but I guess I like to complicate my code myself. Yep. Hope it helps, and goodbye.